Now we can move to a little bit more complicated scenarios where input market or input price affected by how much the industry produce or how many firms there, which is more or less the same thing. Now, the first of these cases where input cost increases when industry produces more. Now, what will happen is all the cost curves of the firm will shift, because we're talking about a cost curve as the graph of the quantity against market price, output price here. So anything that changes but not the market price of the output will shift the curves. Now, and things apply for the cost curves as well. So in short, cost curves will shift. And because they will all shift, we will not care about the shape of the MC anymore, but rather we will focus on the lowest point of AC, because we know for sure MC will cross AC at this minimum point. And that's the most important thing to remember. Then, as I said, if entry and exit of firms have an impact on the input price or cost, then the supply could also increase or decrease as a consequence. So some reason for increasing average cost may be competition for scarce resources, understandable, no? Like if, for example, football industry, good, excellent, famous football players very scarce. No? So competition for this resource will ultimately make the input price goes up. And external costs, for example, with pollutions the firms produce, when they enter, they pollute the air more, and then ultimately they have to deal with policy forces or have to spend extra costs on the environmental solutions and so, and that make the average cost, when you take into account these costs divided by total output, make the average cost increase. Now we see what happens with this increasing cost case. Now, so in the first period where the game starts, let's say it like that, with the old long run equilibrium. So this is initial long run equilibrium, but it's also the short run equilibrium for this first period, first episode of the game. It's similar to the graph we had before, but here we should actually write SS, short run supply curves. So that cross the demand curve as P1, Q1, and at P1, where SMC cross P1 is where the firm chose to produce small Q1. Same as before. Second episode, again, demand shifts upward. And that means a profit, positive profit for the existing firms in this industry, only for this short run period. Remember, equilibrium, short run equilibrium firms can have positive profit. So this is for the second episode. Now they increase output quantity to Q2 now, in order to respond to this increase in market price at a new equilibrium now. So far up to this point, the story is pretty similar to the constant cost industry case. However, after that, thing will change now. And because new firms entering the market, as soon as they see this positive profit that the existing firm in the industry is earning, of course, they will want to jump in. And when they jump in, what happens? The cost curves will shift upward. So this point is already higher than the original one. So the P3 is higher, much higher than P1, but lower than P2. And this is the new long-run equilibrium. So why? Simply because demand for input increases. So price of input increase. And when price increases, the profit from earn will be less than before, right? Because it gets more expensive to produce now. And for that reason, then the quantity will be less. The last case is the decreasing cost industry case. Now, even though it doesn't sound very feasible, given what we just analyzed with increasing cost case, it actually makes sense in reality for a certain industry. For example, if there's some external benefits that come together with new firms entering an industry, let's think about, for example, personal computer production. Before, if you remember, even before I could remember, because I was small back then personal computer is something really expensive, and there's only a few producers for it. And however, now when more and more players come to the market, it gets cheaper and cheaper for us. So almost everyone, at least here, could afford a personal computer. And that is because they have larger pools of trained labor, and in order to reduce some hiring costs. More and more students trained in informatics, for example, software engineers, and also in Vietnam and in other Southeast Asian countries, they have factories specialized in outsourcing different parts of the computer. And this cluster industry make it more efficient economically, make the cost cheaper. Okay, so it's also efficient transportation or communication networks, like the pork fattening regions in Germany, Northwest Germany. This you may have heard already from another module that you're doing, like vertically or horizontally concentrations like that. Okay. Now we move on to the example of the increasing cost case. Like before, now we have quite a bunch of assumptions, quite a lot of information. This could be confusing. So let's try to guide you through it. Yeah. So I summarize the problem here. We have a demand curve for a goods called stoves. I mean, I know what it is, but it's a strange thing to think about. Anyhow, let's respect the alpha. This demand curve is given by 1500 minus 50p. They also give a long run operating cost. So operating, only operating, meaning there is something else in there. We will see below. Yeah. For each of these identical forms, given by 0.5q squared minus 10. By the way, I numbered these equations because there's quite a lot of information, so just to keep track on it. Yeah. On the other hand, there is one input needed for this industry, is called entrepreneurial talent. Is scarce. So this is the supply function for this scarce resource given by 0.25 W with W's annual wage for this person. And you see that this input supply function is positive slope. So that means increasing cost. And then what is this implication for our long-run supply curves here? There's one more assumption. Now that I come to this point, I realize I miss it. So each form, forms, no plural, needs only one entrepreneur. I always have problem with this word, actually, to be honest. Yeah. So this it was from the firm needs only one person per firm, one and only one, meaning the number of firms total would be equals to the number of this talent supplied to the market, which is QEN. Equals 0.25 W. We could write it as equation 4 already. So that is the meaning of this assumption. The next implication for this is total cost function of the firm is now CQ, but also W, the input price, equals 0.5 Q squared minus 10, and then this is only operation cost now. The cost of the entrepreneur is not there yet, and that cost is what then? We have to plus it, W, the wage we pay this person. And because if you only need one person for one firm, it's just one W, simply so. So this is 5. Okay. Now the task, like before, we need to find the long-run equilibrium, total industry output, firms output, equilibrium price, number of firms, but also now the wage rate paid to the scarce resource, the input price. So let's start slowly. We have one equilibrium. Let's change the color in order not to get confused. equilibrium condition, which is MC equals AC. So usually we start with the cost functions first now. And now what is MC? Look at this. MC is the marginal cost, so take the derivative, 0.5 times 2, so Q minus 10, right? Because there's nothing with Q in W. Equals AC, so now divided by Q, 0.5 Q minus what? Wait, I missed something, so there is Q here and there is Q here. No wonder why. I find it strange. Okay. Divided by Q is 10 left, plus W over Q, right? Now let's solve for Q. We would have put everything with Q on one side. So here on this side we have 1Q, here 0.5. So at the end we have 0.5 Q left on the left hand side. Yeah. Here's minus 10, here's minus 10, cancel out. Still have W over Q on the other side. So let's cross multiply Q to the left hand side also. That means we have 0.5 Q squared equals W, and meaning Q squared equals 2W. Okay, let's stop here for now as equation 6. Alright. We would continue back to this, make use of this equation 4. From 4, we would have N, sorry, that was Vietnamese, equals 0.25 W, equivalent to W equals 4N. And then we could substitute this into here. We could substitute this is 7. And cross it here, W equals 4N. Substitute 7 into 6. We would have Q squared equals 2 times 4N. Meaning Q squared equals AN, and take the square root of both sides, yielding Q equals the square root of AN. And this, let's call it 7. Okay? So now we have one equation of Q as a function of the number of 4. The next step, let's go back to the most basic equilibrium condition. You know what I mean. So at equilibrium, we would have QS equals QD, right? So that means we could write Q as the number of firms n times small q equals (1,500 minus 50q). Sorry, 50p. And let's denote the as A. Also, at equilibrium, the other condition we have is P equals mc, right? If you ask me how would you know step by step at all up to here and how to solve it without somebody guiding you, then I don't know. I mean, because when back to the time I studied, also I was guided, and that is why you need me here now. So just follow it and be patient. So P equals mc equals, where's mc? Q minus 10. That's what we have now, right? And this is equation 9. So we could substitute P in A by Q minus 10. Okay, substitute 9 into 8. Then we would have NQ equals 1,500 minus 50 times Q minus 10, right? Equals 1,500, let's open bracket, minus 50 Q minus, or plus, because minus and minus plus, 500. Okay? Now on one side we have this, on the other side we have NQ. So let's put what with Q to one side. So NQ plus 50Q equals, on the other side, 1,500 plus 500, 2,000. And then factor out the Q. Inside we have N plus 50 equals 2,000, meaning Q equals 2,000 divided by N plus 50. Okay? And this is 9. Alright? No, 10, because I have 9 here already. Now look at this. Here I have one equation of Q. I also have number 7, another equation of Q. So I could now set them equal, right? Because that's all equations of Q by N. On the right hand side of 7 I have N, and on the right hand side of 10 I also have N. So right there when I set them equal, I could already solve for N. That's the first thing we need to find. It's already there. Let's say set equals 7, 10 and 7. That means On the right hand side of 7 we have square root of an. On the right hand side of 10 we have 2000 over n plus 50. Yeah. Then what's next? Square both sides to get rid of the square root. So meaning we would have an equals 2000 divided by n plus 50, everything's square. And that is 500,000 divided by n plus 50 square. Okay, I make a mistake here. So here actually should be n alone. Divided by 8. And this is actually 500,000 because 2,000 square is 4 million. Only divided by 8 it turned to be 500,000. I skipped one line in my note and that's why. So here we could already write n, this is n, not to confuse, okay, times n plus 50 square equals 500,000. And then using some very popular equality that I introduced last time, you could write that n times n square plus 2 times n then times 50, meaning 100n plus 50 square is 2,500. Equals 500,000 on the other side. And that means if you use the calculator here up to this point, but before it, n to the power of 3 plus 100n square plus 50. 2,500n equals, and then minus 500,000 equals 0. Here with this equation we allow to use calculator. No need to do further algebra, and that the result will be n start equals 50. The first thing. Okay. After reconsider, I decided we just go with this part because I'm afraid that if I clear everything, you will be lost. Okay, so now we have n equal 50. So the number forms 50. And if we go back here, substitute 50, n equal 50 into q equals square root of an, then we have q start equal the square root of a times 50, which is 400 now. So the square root of 400 is 20. Now, that is the next thing asked here. Right? So we have N solve, we have Q solve. Then of course we have Q equals Q start times N start. So that means 20 times 50, which is 1000, right? So that is Q star. So 1000. What's next? We need P and W. So easy. Now we would need P equals to MC. Where's MC? Here, right? Equals Q minus 10. Then let's write it up there. So P equals Q minus 10 equals, we have Q which is 20 minus 10, therefore P start now equal 10. Now another tick. What else? W. Where is W? W is one of the first things we have here, right? So W is 4n from 7. Equals 4 times 50 equals 200. Now W star. So everything is solved. A little bit messy, but the main point here is just follow step by step now, and employ all the conditions we have. Good luck. The last case is decreasing cost industry. Even though it sounds very contradicting and even infeasible, given what we have talked about competing for resource with increasing cost case, it actually makes sense for certain industries in reality. So the reason is the bigger an industry gets, it will give incentive for suppliers, the input suppliers of that industry, to also scale up their business or productions, right? Let's think about personal computer, for example. Back to the time, I think even before I could be aware of that, was very expensive in order to have one personal computer. No? Very few people could afford that. However, nowadays you can see that there's many different brands of personal computers, not like before just a few brands, but also computers get cheaper and cheaper over time. That is because the allocation of resource will become more efficient, even either with transportation or logistic, as also because, for example, more people are trained for that job, so it's not human resource is not a scarce resource anymore. Informatics students, IT engineers, or even in Vietnam or other Asian countries, they have outsourcing factories specialized in producing different parts for the computer now. And these factories basically they could produce for any computer brand because the level of specialization in very, very tiny details. Okay, so these things make the cost of producing cheaper. Similar case was like Silicon Valley or even with Hollywood movies. Of course, it gets cheaper if you invest to build the scenes or the stage for that could be reused for many movies than just you build something huge for one movies and then afterwards used for nothing else. You got to destroy it. So all the costs will be on that movie, And now if more movies produced, then you can split the cost with among them. That's the idea of decreasing cost industry. So how will the story go now? First episode, similar like the two other stories. You have a short run equilibrium, which coincides to the long run equilibrium when at this price, the firm earn no profit, zero profit, because as MC cross AC cross MC cross P, zero profit occurred. Long run and short run equilibrium together. Now, in the next episode, demand shifts again outward. Therefore, the demanded quantities higher and the equilibrium price higher at this new short run equilibrium. And firms get that signal because they see that new market price and they use their short run marginal cost curve, which is the same now in this episode, as long as no new firms entering now. Then they use that to find out the new output quantity they want to produce, Q2 small, and they earn some profit because at that point, the price above average cost. Nothing new there. However, the story goes also different now. Instead of shipping upward, like with decreasing case, now the cost curves of the firm shifts downward because it gets cheaper to produce. Then what happened? It's cheaper, then the short run supply shifts more further to the right or more outward. And they produce more, keep free even more, much more now at this new equilibrium. And of course, because there are more products on the market price, the new equilibrium P3 decrease even lower than the initial P1. At this point, and it only stop again when does it stop? Of course, when the profit of the firm's zero. So the firms become less profitable now, not because the cost of production is more expensive, but it's just because market price decrease. Okay? So this is also one discussion when talk about free trade agreement. It takes forever to negotiate, especially with agriculture product and agriculture policies. For those countries that they protect their agriculture industry a lot, that may be the case that at the end, over stimulating production, make it cheaper for the farmer to produce, will lead to decreasing in price now. And that could be the case. So some text to summarize what I just blah, blah, blah. But there's no more information. Okay. So if you connect these two long-run equilibrium, old one and new one, you have a downward sloping long-run supply curve because P3 is now lower than the initial equilibrium price P1, right? And actually, the shift in the supply, short-run supply curves now is much larger compared to the one if that was the constant cascade. Because if a constant cascade, then you would have it here as a vertical line and it crossed D prime over here, it will be less. The magnitude of the shift in supply will be less, but because it's too cheap, then the shift is larger. And remember again that the shift in supply, it will adjust, of course. It's not like one period like what I'm telling you, but of course it happens slowly over time. It will stop at the point where minimum of the average cost and the price meet again. So until the output price cheap as the average cost. Then we also have the all price elasticity for supply, but in the long run. So from the formulas, nothing different from the case we know before, but it's just that now we change to the long run quantity. LS is for long run. Okay, at the long run equilibrium. However, the sign of the elasticity can be different. So in the short run case, we assume that we always have the positive elasticity. Now the sign can be different. For constant cost industry, we have seen that the elasticity is infinite. No price change for infinite change in quantity. For increasing cost industry, the elasticity is positive because the long run supply curve is positive slope. And for the decreasing cost industry, we have negative slope, meaning negative elasticity. What happens, especially to the number of firms in the industry when input price increase? It's not easy to say one answer. For example, in this case, the shift in the AC is much larger than the shift in the MC. The typical firms in this case will increase input from Q0 to Q1. And because input per firm increases, so the number of firms in this case will decrease. That at least we can say. However, there may be the case that Q1 turn out to be on the left hand side of Q0 star. That is when, for example, I could draw it like this. No. AC1. So the AC shifts only a little bit compared to the MC. So Q1 start is here, and it is smaller than Q0 start. Then the number from could either be larger or smaller than before, depends on how total output of the industry changes relative to the output per firm, or they could sometimes call it the firm size. If you're interested in that, could go back to the comparative statics of the long run equilibrium in the textbook. Yeah. For now, let's just stop here.